All right, guys. So these days, obviously, the economy has gone down to shit, and there's a lot of people that have gotten laid off and all of that stuff. So then I was thinking, or I was seeing a lot of these videos and stuff about people doing side projects and people doing productizing services, coming up with SaaS companies and stuff like that. So I decided to give it a shot. And so what I'm going to do in the next couple of videos is I'm going to create an app that is a job posting app, and it's going to be dedicated only to developers. So no project managers, no pure managers, no PMs, no executives, no nothing. Just people who are writing actual code. And I'm going to build an app dedicated to jobs for them. Um, the the application is going to be written on the back end with Rust, and then on the front end with React and JavaScript, TypeScript, all that stuff. And I'm going to give it a shot. And what I'm going to do, or the way that I'm going to do it, is I'm going to make it completely open source. So you'll be able to go to my GitHub, download all the source code, copy it, do your own thing from day one. And then everything related to this endeavor, I'm going to post on my channel. So the development, which is what I'm going over today. But if I, put it online and then it starts making money, then I'll post that, how much money I'm making, where it's coming from. I guess I'll be able to do some analytics and stuff like that on it. I'm not entirely sure how the backend being entirely in Rust is going to go. There's certain things that I'm going to probably need to use an emailing service, again, some analytics type stuff, various other services. So there might be a need to put in some sort of intermediate node service so that if there is no API for some reason that I can hook into with Rust. I mean, for the most part, I expect there to be some sort of web API for like 99% of stuff, but there might be something like payments or something like that, because I'll have to obviously charge if I'm going to make money. So who knows? So this is part experiment, part just trying stuff, part doing a side project and trying to run a business. And, if I'm going to activate it as a real app, obviously the code has to work. So there might be some stuff that I and we can learn from it technology wise. So yeah, that's what I'm going to do. All right, so what are you looking at? You are looking at the back end. It is not complete, but there's a fairly sizable chunk that is complete. So I figured actually it would be better to show it to you guys raw when it's not finished and pretty and all that stuff. So let's get started. So if we start on the main file, if you know anything about Rust, and this video is going to be entirely Rust, I'll have kind of dedicated videos. The Rust backend will be one video, then I'll do the React front end on another video, and I'll keep kind of bouncing back and forth. But anyway, so this video, if you're not entirely familiar with Rust, I'm gonna do my usual line by line explanation. So it shouldn't be too hard, but yeah, if you are not new to Rust, you might be still a little bit confused by this setup right here. And what's going on here is that, yes, I have the main because this is a binary project, but as you can see, I don't really have any code in it. And the reason for that is because I have integration tests inside of this folder. and therefore I am making my modules exposed as a library, right? So that the tests which run as an independent binary, can have access to the modules that are going to be running in my app, right? So the way to do that is to do this setup right here. Now, I haven't touched this file in a while, so some of this is not fresh in my memory, but obviously you can see in the source folder we got lib.rs, and that's really where the jumping off code is going to be at, and I'm going to explain that in a moment, but I want to talk about the setup first. And then you got, the main binary itself, right? You got the binary and you got the library, right? And then the name of the project, okay? And then you just have typical Actix and Actix Web related crates. So just about everybody uses Chrono for datetime. You got where's Surdy? Surdy for serialization stuff. You got mockall for mocking. Lazy static for using async inside of traits. Various future stuff. Fake for creating fake test data. And then .env for environment variable stuff. And then, some relevant to those packages, some relevant dependencies. So then we have our modules publicly exposed. We have whatever we are using, and then you could kind of think of this run function as the real, main function, right? And then at the top, you've got a initialization of logging, and then you've got the setup of the ability to get environment variables. And the first one is the host, which I think I put in as localhost, unless it's because I have this set up as either a .env or a Docker. Either one will work. Sometimes I run the local because I want to get more logging information, immediate logging information in like the terminal and stuff. So sometimes I just run the local. But either way, even with the Docker image, you can get access to the environment either way. And you have env var, so the variable, grab the host, env var, the port variable. You have to parse it because it's a number. So then you grab that number and then you use them to bind, meaning bind your server, right? So you have all that, and then you have app data, which is the global variables or global data that you're going to be sharing across your application instance. And there's actually multiple instances of your application by default per core, one thread per core. That's the default behavior. And this guy is the actual HTTP protocol server itself. And then this guy is the business logic, meaning your business logic, as well as any middleware that you might see, which is initialized by the wrap function right here. And then obviously this is the logging. And this is sending the app data to all of the instances of the app. Again, one per thread, one thread per core. I haven't bothered to add the actual routes yet. I'll show you that. I'm still building the routes out, so I'll show you the adding of routes in a subsequent video. If you can't wait, I have a couple of videos on specifically teaching Actix Web, so you can check those out in my channel. This isn't really deep diving into teaching Actix Web or teaching React or whatever. It kind of assumes that you're already somewhat familiar with those technologies, and I'm just showing you my implementation and how I'm going about building this specific application that I'm trying to build. So again, if you're not new, then this is if you are new, then this is probably not the video for you. All right, so let's do this. Let's go through some of the most important routes first, and then fall through the route into the repository layer, which is connecting to a Postgres database. And let's do it like that. So the most important routes would make sense that it would be stuff related to the posting of jobs, because this application is a job posting application, right? So yeah, it might make more sense to do a little visit of the database schema first, just so you see what's there. Now, be warned, I intend to slightly modify this schema in a couple of the tables. So it's going to change slightly over time, but 99% of it should remain as you see here. Now, this source code is already available if you want to just download it right now and follow along. But anyway, I'm going to continue. So obviously you have here a table company. This represents the employer that is submitting the post, their company. So you got a name and you got an ID. Then, of course, we could have multiple countries where these jobs are being, at least the company is centralized from, right? Not necessarily that the job is on site, but at least the company is headquartered in. And then here you have the programming language, because again, this is a programmer specific app. So I put in some default languages. So it's my intention not to support 10,000 languages from day one. I intend to support only these languages that you see here, because at some level I want to be, how should I say, somewhat different from the other jobs related sites that I've seen, even the technology ones, because I don't really see that many sites that are dedicated only to programming. As far as I know, there aren't any. I mean, there's certainly ones that are dedicated to IT in general, like Stack Overflow has their jobs thing, but I don't think there's one dedicated to coding only jobs. But I haven't really investigated that, so I could be wrong. But anyway, then you have the industry. A lot of these tables are the same fields, and I kind of thought about creating one table and, you know, putting like a type flag on it and stuff like that, but nah, I don't. Yeah, I'm not into that kind of stuff. It just makes everything more annoying and complicated to deal with this typing flag. So I'm not going to do that. Feel free to do that if you want to. And then, of course, I have some default data again. And again, I'm going to limit myself to the specific industries. And all of this limiting that I'm doing, right? Like a lot of you guys might be like, what is he doing? Why is he, almost guaranteeing that this thing is gonna fail because he's like self-limiting and all of this stuff. And the truth is, like 97% of companies fail. So the notion that this is gonna be successful is kind of ridiculous, right? Like you see these videos on YouTube about how they're gonna do this and that and whatever. Nah, I don't think so. So if I'm gonna do it and it's probably gonna fail, then I'm just gonna do it however way I feel like doing it, and that's it. So the salary is obviously the salary range. To me, a salary for a experienced developer, which is what this site is intended to be, of less than 200,000 USD is an insult that I simply will not tolerate. So this is the lowest salary that I allow. And then the salary going up to 500K isn't actually the highest salary. It's 500K and beyond. So that's the way that I have it set up. If you want to copy the code here and do your own thing, feel free. If you think I'm wrong and you want to switch it up or do whatever, put in your own values, go right ahead. So then you got the developer table, and you've got ID, created at again, and you got the username, the full name, the email, and then their primary language ID, right? Going off of the same table, programming language. Email is, I kind of hedged about this because like, I don't want your email and I don't want to be involved in that sort of stuff. But unless I do this Web3 and crypto, which is just going to make everything complicated and take longer, not to mention the fact that so many people still don't use Web3 and crypto. So then I kind of bit the bullet and I just stuck the email in here. So who knows, this might change over time. Next, you have employer. It's a lot of the same stuff, except you have the associated company ID. And then, of course, you have the most important table, the jobs themselves. Now, again, my app, my way. So I really don't care how it's done in the business, quote unquote, right? I'm going to do it my way. So you can see this is very constrained. It's extremely constrained what you can put in here. And I am deliberately doing it this way because the way that companies kind of offer up their jobs honestly kind of pisses me off. So you will, if you come to this application wanting to post jobs, you will post it in this way or you will not post it at all. So you have a title, you have a description, you have whether the job is remote, you have the headquarters country ID. This is the one that I'm considering changing because I'm like, okay, the company has a headquarters, but then the job itself might be on site and not in the same country where the headquarters is. So this, although this field might remain, I might add a secondary field. And then you have primary language ID. You can see not null, so not choosable. You have a secondary language ID, nullable. There is not a third language. So these job postings where they have 14 languages and they expect you to know AWS, Google Cloud, what is that called? Azure, Cloudflare, Kubernetes, GitHub Actions on top of everything else. It's like, no, go somewhere else. Industry ID. So that's that. Salary, you guys saw all the tables. And then here are the constraints. So I'm keeping things very simple for now. I did add unique to the email, but that's about as sophisticated as I'm getting. So yeah, so that is the schema of the database. Again, Postgres. And then let's start with the most important route, which is the jobs route. So if you don't know what I'm talking about the routes that will be associated to the actual server, right? Again, if you need details, this is not the right video for you. You should go to one of my other videos, or there are a ton of Actix web videos on YouTube, so you could check those out if you want. All right, let's close this, make it more visible. Oh, because I grew the font size so you guys could see more clearly. That's why this is. All right, let's just swing this down. All right, so what's going on here? So we have our create job route. Yes, this is a function, but this is a route. And we are using generics. Okay, and we have our app data. So our Actix Web shared global data. And then this route is going to be a post. So then I am JSON enabling it. So this data will come in as JSON. And then internally, I am calling the actual repository function itself, as you can see here, coming off the repo. So let's explain this line over here in detail, because as far as I've seen, nobody writes Rust code like this. And honestly, I don't know why, but whatever. So if you come to this base.rs file inside of source, src common repository, yes. So if you come into this file, you're going to see a bunch of base and helper functionality for the repository layer. So this is one struct that I'm using to contain response ID data. Again, I'm going to explain most of this stuff when we get to the repo layer, but I need to explain the reason for having this repository trait. So, all right, in order for this to make sense, I need, here it is. Okay. So the app state, again, the global state of my Actix web server has a repository object, right? You just saw it in the route right here. So this repository object is of type T, but that type T must implement a repository trait. So what is that repository trait? Well, that repository trait is a trait that indicates that the repository type is specific to making database repository calls. And that's what this trait signifies. So although it's not a marker trait because it has, it has something inside of it, it's sort of a marker trait in the sense that I want to be clear that you can't just drop anything that you want in here. It has to be specific to repository capability. So that's this guy's main reason for existing. Now, if I bother to do that, then I might as well put an initializer in here as well to define, so that whatever struct you cause to implement this trait will have the appropriate capability, right? And in this case, it is init as opposed to new, because the initialization requires async, and you don't put that on new because that's not idiomatic. So I'm creating this init function to do that. So then I have that trait, and then I have my production code struct that I'm gonna actually hit the database with, and it has a private member. Okay, very important. And here is my repository implementation with the init. And as you can see, I am making a awaitable call here. And this call is ooh, I left out the async stuff. All right, I think I must have added this for some other purpose, but whatever. This is an app under construction, So eventually I'll update this with whatever I was intending to put in there. But anyway, so we have this, where is it? Okay. We have this trait, right? Con getter. And then the con getter also demands that whatever is going to implement con getter also implements repository. So now we're covered. Now I know that whatever is implementing con getter is a repository object. Okay? And then con getter, as the name implies, is a getter setter of a private member. So this is the actual function getter. And then this function getter is going to return a reference to that connection, which we need in order to connect to our database and blah, blah, blah. Oh, that's what happened. All right. Confused the crap out of me. All right. I should have named this better. Yeah, this is the one to get the internal connection for the struct type. This is just to get a connection pool instance. I should have named this get connection pool. Actually, you know what? I'll name that right now. Yeah. Because it was confusing. So clearly this is async, right? So you could see right here, right? Because I changed the name. Yeah. So anyway, yeah. So then what is the connection pool, or how does the get connection pool work? So it gets a lot of the stuff from the environment variable. So the Postgres, so this stuff right here, right? Because the server has to be able to connect to the database, obviously. So it goes, and from the environment variable, again, whether it be the .env or the Docker image, it gets the appropriate environment variables, and then it creates our Postgres URL for obvious reasons. And then we do the connection, Postgres URL, the connection. We take that connection and ultimately we return it, but we also need to run a migration to our database so that our schema is properly applied. In other words, if our tables are missing, if this is the first time this thing ran, then our tables won't exist. So this portion of work is to create all of those things. And if it runs the second and third and fourth time and the stuff is already there, then it doesn't run it again. So that's what this functionality is about. All right, so going back to this guy. So now we know what this business is about. So we know that there won't be any accidents. Whatever repo that we pass in here to app state is definitely going to be a real repository object. So we're safe there. So then what is this? So what this is a trait that has the a wrapper function to insert a new job. Sometimes when you're doing hours and hours of coding, you end up like losing your mind and doing ridiculous things. But anyway, so you have this function, you have a new job parameter, create me a new job. We don't need to review that. And then if it's successful, you have an ID come back. If it fails, you have an error come back. The implementation for that, and why I said this is just a wrapper, is to take this internal insert job and to grab that getCon function that we saw in our base.rs file. So this guy right here. And get that connection and send in that new job to the real worker. And I'll go into more detail on the repo stuff later. But in here is the real worker doing the real database work. So then why in the heck do I bother with this? Well, if you want to do unit testing, you need a unit under test. And the unit under test for create job is not insert job, is not repo.insert job, right? The unit under test is actually all of this stuff. That's the actual work that create job does. The work that insert job does is a totally separate, distinct thing. Therefore, if we want to do true unit testing right here, we need to be able to isolate, separate, and mock stuff that is not the unit under test, which is this guy right here. So by doing this and using generics, having this trait and using generics, I'm able to mock this guy out. So that was insert job, right? On the insert job FN trait right here. So I just mock that function insert job and I return a hard-coded value. So then now I know that when create job runs with my mock database repo object, right? Does this show it here? See, impl repo. I implemented for mockdb repo in it using repository. So that's why this guy is accepting T, because T is of type repository. So this, even though it's not the real repo, is being accepted into this function. So then I take this thing and I pass it in, and again, it's not the real repo, but it is still accepted by create job. And then when it calls the insert job, it will actually call this guy, the fake, the stub, the mock, whatever language you want to use for it, the hard-coded value. And then this runs, the result comes back. I check it, is it 1? Because that's my hard-coded value. If it is, then my test passes. And that's it. All right, so let's do one more. Let's switch it up and do a getter. So I have the get. So what I'm trying to do with this syntax that you can see here, you see where I have insert on the repo side, on the database side, and then I have create on the route side. So to avoid confusion, to make things clearer, whenever I'm doing repository level stuff, I'm using database SQL-like language, insert, query, delete, stuff like that. And then whenever I'm doing the route stuff, I'm kind of using sort of like HTTP verb sort of language, just to kind of keep them distinct from each other. So anyway, so we have query job, right? So real quick, it looks like this. We have a job, queries by ID, again, the internal. So again, the repository, and then the app data. And then here we have a path, because I'm not using JSON. I'm getting the variable from the path itself. In this case, since I know it's an ID all the time, I just take the primitive value and just use it directly. So then I get a result. Then I have to make sure it's successful, so I match on it. It could also be optional, by the way. So that's why I have this secondary match. And then I need to convert it into a type format that the routing system, meaning ActixWeb, can understand, which looks like this. You have a type. It needs to be serializable, meaning taken from a Rust type and converted into a JSON string. And then I have to implement the responder type. This is an extractor from ActixWeb. If you don't know ActixWeb, again, you can check out my other videos, or you can pay for one of my Udemy videos, which goes over the entire ActixWeb and SQLX frameworks. And anyway, so you have that. Then you implement this function. You convert to a string. You use that string in a regular HTTP response body, whether it's a success or failure. And then as long as you have that implemented, then you can return the object without further boilerplate. So in other words, just give the fields that are required, and ActixWeb is going to do the conversion for you. So like I said, it's optional. So we have the sum. The return has to be wrapped because it's a result. It could potentially be nothing. So we have this option. And then if it's an error, we return the error. And the testing is the same deal, a mocked implementation of this to test off of. Now, where is it? So I did these unit tests, right? So I have a bunch of unit tests here, but these are the only unit tests in my app. Okay? And my repository layer does not have any unit tests. And why? Because I found that I would say it's mostly because of Rust, but there's some annoyances with SQLX and ActixWeb and stuff like that that just make creating unit tests for the SQLX layer just very annoying and just a huge time suck. And this isn't really about, doing the most perfect, awesome Rust app in the world. It's really about getting a side project up and running. So I'm not going to go crazy over this thing. And on top of that, I find that the unit test at this layer is kind of a waste of time too. But if I'm giving you my honest, sacrilegious opinion, I know you're not supposed to say that. All the unit test people are going to downvote my video now. So what I do instead is I put all the testing that I want to do at the SQLX layer, in the integration test folder. That's what this is. The test folder on the root of your project is going to be the integration tests that you put in here. You don't put unit tests in here. So create job, we kind of already went over that. So to create two jobs. Oh, okay, I'm also calling the getters in here. So let's just go over this. So I create one job and I get it back. So it's kind of it's an integration test. So, I'm doing multiple things in it, right? So we have our repo, and this time it's our true blue production repo. We initialize some fixtures. I'm not going to go over that. You can go over it if you want. We have some fake data, right? So again, this is from the fake crate. So we have our insert company. We already went over this, but a new company needs a company name, so I give it a fake name. Then we have the result. I get a company ID. So then I insert an employer, which is an individual account, as you can see here, associated to that company. Then we get the list of possible countries, get the list of possible languages, industries, salary ranges. Then we insert a new job, right? Because this is the test jobs integration test. And we take all of our data that we just created and we start making use of it, right? Some of it is the fake data. Some of it is the data we saved into the database, languages, countries, etc. And then we make sure that that data is for real saved into the database and for real gotten back from the database. So then I clone that because I can't just use it and consume it. Although why, I must have had some other asserts below this, because I don't know why it won't let me. Yeah, if I use it only once, I must have had some other asserts down here that were the hell is this? That were maybe going off of the other fields, like is remote, the string fields. What is it? Description or whatever. And then it was complaining about that. But anyway. So yeah, I don't think you need a clone here. So anyway, if you run this, it will work. So in fact, let's run it right now. For you boys and girls at home, don't make changes live and then run your tests again. 99% of the time they will fail. But by some miracle, everything worked. So, good. All right. So then, that's an overview of the application. I'm mulling over in my head right now if I really want to go over all the repository stuff, because it's just super boilerplate, repetitive, very boring stuff. So in this video, I'm gonna stop right here. If you have questions, you feel like I need to give more detail, maybe explain the Docker stuff or something, leave a comment. Otherwise, I will see you on the next video.